Hello everyone. I'm Ajaya. So let us start learning mathematics together. Let us start with our first chapter, that is number systems. The numbers which we have learned till today can be classified under real numbers. All numbers we have learned are real numbers. Let us go with the bottom up approach. Let us start with natural numbers. Natural numbers are all counting numbers. For as we know, it is 1, 2, 3, 4, etc. Till infinity. Now we know what is zero. Indians discovered it. Um, Now whole numbers. What are whole numbers? Whole numbers is combination of zeros and natural numbers. That is 0, 1, 2, 3, 4 and so on. And there are negative integers. Negative integers are negative part of the whole numbers. That is -1, -2, -3, -4 and so on. Now there are integers. Integers are combination of negative as well as whole numbers. For example, -5, -4, -3, -2, -1, 0, 1, 2, 3 and so on. And fractions. Fractions are anything that can be expressed in the form of a by b. As we all know, we have seen some fractions, 1 by 2, 5 by 6, etc. All these integers and fractions are together called as rational numbers. And there are another type called as irrational numbers. The square root of 2, square root of 5, which are not perfect squares, are called irrational numbers. All of this together constitute real numbers, which we all know today. Let us look at each category in detail. So let us look at natural numbers. They are the set of all non-fractional numbers from 1 to n. That means all the counting numbers like 1, 2, 3, 4, 5, 6 until infinity, until how much ever we can count, is all called as natural numbers and it is denoted by n. What are whole numbers? If 0 is adjoined to natural numbers, then the collection is called as whole numbers. That means if I add 0 to this set, it becomes whole numbers. The same natural number set, this is the natural number set, I have added 0 to it. So it becomes a whole number set. 0 and natural numbers. Now let us look at integers. All natural numbers, negatives of natural numbers and 0 together form a set of integers. That means we know that the natural numbers are counting numbers that are 1 till n. And the negative of natural numbers, that means if we add minus sign to this, the negative of this is minus n to -1. The negative of natural numbers and 0 together form integers. This is denoted by z. Z comes from the word zahlen. Zahlen is to count in German. So we can further classify them into negative and positive integers. So what are negative integers? It is denoted by z minus, showing that they are negative. They are all the negative integers, that is -1 till -infinity, -1 till -infinity. And the positive integers are denoted by z plus, indicating as positive integers, and they go from 0 till infinity. 0 is included as a positive integer. So when I define a negative integer, I can define a non-negative integer. A non-negative integer is nothing but the positive integers. And when I define a positive integer, I can define non-positive integers. That is nothing but our negative integers. -1, -2 till -infinity. Let us look at fractions. A numerical quantity that is not a whole number. That means let us take the circle as a whole part. And if I remove a quantity of it, it is called a fraction. For example, 1 by 2, 1 by 5, 18 by 17, 128 by 333 are all examples of fractions. These are fractions of a certain thing. This can also be 1 by 2 can also be expressed as 0.5. 1 by 5 can also be expressed as 0.2 and etc. So we can see that fractions can also be expressed as decimals. But not all decimals are fractions. To know this, we have to learn more about decimals. So we can classify them as three types of decimals. One is terminating. What is terminating is the remainder, or when we divide a number with another number, the remainder is 0 and the quotient has an end. For example, if we divide 5 by 2, we know that it is 2.5. So here it does not it is not repetitive, it ends, so it is called as terminating. We have another type of decimal that is non-terminating and repeating. That means it does not end, it goes on until infinity. But what happens here is it is repeating. That means the 1 2 1 2 1 2 is repeating again and again. An example for this is 5 by 3. That would give us 1.6666. So here the 6 is repeating again and again and again. So this is called as non-terminating and repeating. So both of these can be expressed in terms of fractions. But we have another type that is called as non-terminating and non-repetitive decimals. For example, we have the value of pi, which is 3.1415926 dot 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 dot. It goes on until infinity. If we see there, no sequence is repeating again and again, and it does not end. So it is called as non-terminating and non-repetitive. And we have the value of root 2, that is 1.414213, etc. It goes on. So we can see that the sequence is not repeating. All these numbers we cannot express in terms of fractions. That is in the form of p by q. Okay, so this type of decimals cannot be considered as fractions, but these are considered specially and they are called as irrational numbers. Irrational numbers. So before we learn about irrational numbers, let us learn about the rational numbers. What are rational numbers? Rational numbers are a ratio of integers. It comes from the word ratio. So the number which can be written as a ratio of two integers. That is, if p and q are integers, if I write two integers in the form of p, any integer in the form of p by q, or any number in the form of p by q, then it is called as rational number. It is denoted by q. Q is equal to p by q. Here I am specifying that the denominator q should not be equal to 0. Why am I doing that? Because if I divide anything by 0, any number p by 0 is not defined. We don't know what that means. So that is why division by 0 is not considered. Here, if we see, for example, the example for rational numbers can be 1 by 2, 5 by 6, etc. So we can give some more examples also, like 4 by 8, 8 by 16, etc. So if we look at this, 4 by 8, if I divide this, I can write this as 1 by 2. If I write 8 by 16, if I divide this by 4, I can write this as 1 by 2. So it is all these are same. That is why they gave other names, called other names. So the numbers which are multiples, like which are have more factors than one itself, that if they are not co-prime, then it is called as, so these type of ratios are called as equi equivalent equivalent rational numbers. That is why while writing that, we also write that the P and Q should be co-prime. That means a common factor for 5 and 6 should only be 1. There should be no other common factors. Like for 1 and 2, only 1 is the common factor. So this is an rational number. But the multiples of these are called as equivalent rational numbers. Any integer can be expressed in the form of rational numbers. So let us take 4. 4 can be expressed as 4 by 1 or 8 by 2, something like this. So 4 is a rational number. 4 minus 3. Minus 3 can be expressed as minus 3 by 1. 5 can be expressed as 5 by 1. So all these numbers can be expressed in the form of P by Q. That means an integer divided by an integer. So all integers are rational numbers. So looking at this, we get another question. Is 0 a rational number? Yes. 0 can be written as 0 by 1 or 0 by 2 or 0 by 3 or by any integer. Everything is equal to 0. That is in the form of P by Q, where P is also an integer, Q is also an integer, and the denominator Q is not equal to 0. And if you look at this, P and Q both are co-prime numbers. Co-prime. So this 0 is also a rational number. Irrational number means which is not rational. Not rational. So irrational number cannot be represented in the ratio of integers with no common factors. Like if we take root 2 as an example, this cannot be expressed in the form of P by Q. This cannot be written in the form of P by Q. So, and it has an, as we all saw, it has an non-terminating and non-repetitive sequence of decimals. 4, 1, 4, 2, 1, 3, and so on. So it is not, the decimal points, decimal values are non-terminating, it is not ending, and it is non-repetitive. So most of the roots which are not perfect squares are, for example, irrational, like root 2, root 3, root 4. 4 is a perfect square. That is, root 4 is equal to 2. So it is not an irrational number. It is a rational number. And root 5, 5 is not a perfect square. Root 6, 6 is not a perfect square. So it is an irrational number. Root 7, 7 is not a perfect square. So it's an irrational number, and so on. For and pi, our value of pi, that is 3.1415 and so on. This is also an irrational number. So now let us summarize that into real numbers. So whatever we learned till now are real numbers. A number that can be found on a number line. We all know how a number line looks. It is 0, 1, 2, 3, it goes on until infinity, -1, -2, -3, and it goes on until minus infinity. Okay, any number in between also, that is 1.83, 1.92, any number which we take on the number line are called real numbers, and it is denoted by R. Okay, so we have a set out here. So real numbers is set of all the numbers we know. So for example, what are natural numbers? Natural numbers are counting numbers 1, 2, 3, and so on. And whole numbers includes natural numbers, and 0 is a whole number. This with 0 makes up whole numbers. This whole numbers with the negative integers -1, -2, -3, -4, and so on makes up the whole integer set. These integers with fractions like 5 by 4, 7 by 8, and so on makes up rational numbers. So, and we have as we saw, we have another category called irrational numbers, for example, √2, √5, etc. This make up irrational numbers. Rational numbers are different from irrational numbers, but they together make up real numbers. We would be learning in our higher standards that there is another set of numbers called as complex numbers. We would be learning it in our POC. This includes the whole of the number system. So this is the Venn diagram of number system. We saw that any number on a number line is a rational number. So now let us see how to represent a rational number on a number line. For example, I have taken 3.765. So let us represent this on a number line. So how do we write a number line? We start with a negative number, -1. Number line. So by seeing this, we can know that this number is between 3 and 4. 3.765 is between 3 and 4. So what I'll do is, I will zoom this part. I'll take a magnifying glass and I'll zoom this part. So when I zoom this part, what happens is from 3 till 4. Okay, so there if I zoom this part, I would be getting 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. Okay, I would be getting 1 decimal point. Now if I look at this, I zoomed to the 3 part. Now I know where 3.7 is. Now I have to get to 3.76. That means I know that 3.76 is in between 3.7 and 3.8. So I zoom this part. So when I zoom this part, what happens is, let us say I take this is 3.7. So it would be 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.78, 3.79, and then I would get 3.8. So if I look at this, I want 3.76. So I know 3.76 is here, but the number I want is 3.765. So the number is greater than 3.76. So it is greater than 3.76 and it lies between 3.76 and 3.77. So the number lies in between here. So I zoom this again. So what happens? Let me take this as 3.76, 3.77. So this will be 3.761, 3.762, 3.763, 3.764, 3.765, 3.767, 766, 3.767, 3.768, 3.769. So I want 3.765. So where is 3.765? 3.765 is here. So this is the point I wanted. So by looking at this example, we can see that as the decimal places increases, we need to keep on zooming it. And as we keep on zooming it, we get more and more numbers. So if I look in between 3.765 and 3.767, I have again 10 numbers. I have again 10 numbers. I have again 10 numbers. So in between any 2 points in a number line, I have infinite numbers. I have infinite numbers. Any 2 points between the number line. I can take between these 2 points also. I have infinite numbers. That means I can't count how many numbers are in between these. Okay, we have to be clear on that. It is not that only 10 numbers are there in between. There are infinite numbers in between them. For our convenience, we are writing 10 numbers, but there are infinite numbers in between them. We represented a decimal. Now let us represent a fraction. Represent 5/4 on a number line. So let me take 5/4. 5/4 can be written as 1/4, right? If I divide 5/4, it can be written as 1/4. Where you can verify this. 1 plus 1/4. 4 plus 1, it is 5/4. Okay. So 1/4. That means it is 1 plus 1/4. What is that? If I check on the number line, if I go here, -1, 0, 1, 2, 3, 4. If I look at here, it is 1 plus 1/4. That means it is greater than 1. So it lies somewhere in between here. So if I look at this, it is dividing the remaining part. That means this remaining part into 4 parts. And this lies on the first part. So if I divide this into 4 parts, this is the first part, this is the second part, third part, and the fourth part. 4 equal parts. This is the first part. So this is 1/4. So this is the point which I needed. So this is 1/4. Now, okay. Now let us do another example. Let us represent 12/5 also. So 12/5 can be written as 2 plus 2/5, right? So that means by seeing this, it is 2 and it is greater than 2. After 2 till 3, it is dividing the place by 5 places. So I have to divide this into 5 parts. So this is the first part, this is the second part, the third part, the fourth part, and fifth part. I have divided that into 5 equal parts. And this is on the second part. So 1 and 2. So this is 2/5. So 2/5. So the point which I wanted is this. So this is another analysis of fractions. Again, here you should remember that there are infinite numbers between any 2 given points on a number line. So let us take a negative number, minus 5 by 4. Let us represent this on the number line. When I get minus, I get confused. Do not get confused. So minus 5 by 4 can be written as minus of 5 by 4. That means 5 by 4 is known to us. We have already done it. Let us do it again. I have to divide 5 by 4. So 4 ones are 4. The remainder is 1. And now 1. So it can be written as minus of 1 plus 1 by 4. So let us represent this on the number line. So if we look at this, where does the number lie? It lies between minus 1 and minus 2. It is greater than minus 1. It is 1 plus 1 by 4. So as we did earlier, we have to divide the line between minus 1 and minus 2 into 4 equal parts. Into 4 equal parts. 1, 2, 3, 4. There are 4 equal parts. Now the first part is 1 by 4. So this first part is minus 1 minus 1 by 4. That is equal to minus 5 by 4. So this is the point which I was looking for. Okay. Now let us take another example. Let us represent minus 3 by 4 on the number line. Minus 3 by 4 can be written as 0 plus 3 by 4 minus of, right? So that means it between 0 and minus 1, I have to divide the line into 4 parts. So on that, the third part is minus 3 by 4. 1, 2, 3. Third part is minus 3 by 4. So this was the point which I was looking for. I believe you are clear with this. And again I'm telling you that there are infinite numbers between any two given numbers on the number line. That means even if I take the smallest one, there are infinite numbers in between them. So do not get confused that there are only 4 numbers in between 1 and 2, or minus 1 and minus 2, and 0 and minus 1. There are infinite numbers. And we have to keep in mind, okay. So while writing this, let us take, I have written minus 5 by 4. We have represented minus 5 by 4 over here. I will ask you to represent minus 10 by 8. So where do you represent that? That is also the point of minus 5 by 4. Because if you divide this by 2, you'll again get minus 5 by 4. And even if you minus 15 by 12, if you divide this by 3, you'll again get minus 5 by 4. That is again this point. Minus 15 by 12 is again this point itself. So never get confused. So whatever number is given, we have to make sure that the numerator and denominator are co-prime. In this case, 15 and 12 are not co-prime. We have 1 and 3 as the common factors. But if we come to 5 and 4, only 1 is the common factor between 5 and 4. So they are co-prime. So we should not get confused with this number and this number. Both are same. We have to divide this and make them into co-prime numbers and then plot it. And we have to always keep this in mind. Between any two real numbers, there are infinite real numbers. Between any two given points, there are infinite numbers. This is very important. Never forget it. Now let us go for a new type of problem. This is insert 5 rational numbers between 1 and 2. That means I have 1 and 2. They are asking me to insert 5 rational numbers in between them. I know that there are infinite numbers, so I can insert any number. I'll write 1.1, 1.2, 1.3, 1.4, 1.5. I inserted 5 rational numbers. But these are in the form of decimals. So we saw that decimals can be rational as well as irrational. So how do I know if they are rational and irrational? They should be represented in the form of P by Q. Only then I know they are rational numbers. Okay. Now let me represent that. So now let me represent them in the form of ratios. For this, there is a simple method called the midpoint value. What is that? I have two numbers, 1 and 2. I'll take 1 as R, 2 as S, and I find the midpoint in between them. That is 1 plus 2 by 2. That is 3 by 2. So 3 by 2 lies in between 1 and 2. So that is also a number. So we keep on doing this until we get 5 numbers. We'll start with this. We have 1, we have 2. And we will take the midpoint of these two values. That is 1 plus 2 by 2. That is equal to 3 by 2. Okay. So this is a number. Now what I do is I take the midpoint between 1 and 3 by 2. That is 1 plus 3 by 2 by 2. Okay. Now I wanted to remind you with some, okay, 3 by 2. So that would be equal to 5 by 4. And I would take a midpoint between 2 and 3 by 2. 3 by 2 plus 2 by 2. That is equal to 7 by 4. Okay. Now what I'll do is I will take the midpoint between 1 and 5 by 4. That is 1 plus 5 by 4 by 2. That would be equal to 9 by 8. And I would take a midpoint between 7 by 4 and 2. That would be equal to 7 by 4 plus 2 by 2. That would be equal to 15 by 8. So now I can easily write the numbers in between them. So it is 1, 9 by 8, 5 by 4, 3 by 2, 7 by 4, 15 by 8, and 2. So there are 1, 2, 3, 4, 5. 5 numbers, 5 rational numbers inserted between 1 and 2. So this is one of the method where we do not go wrong. Or else if we find the numbers and find the fractions of each number like this, it is a tedious process and we might go wrong with that. So we will continue with another example. We need to insert 3 rational numbers between 3 by 5 and 4 by 5. So I write 3 by 5 and 4 by 5. So I have to take a mid value between 3 by and 4, 5 and 4 by 5. So that is 3 by 5 plus 4 by 5 by 2. So what would this be? This would be, if I add them, it is 4, 5, 6, 7. It would be equal to 7 by 5 by 2. So this would go here and get multiplied. So this would be equal to 7 by 10. So before proceeding, let us revise some basics. A by B divided by C is equal to A by BC. This goes here. This gets multiplied. If it is A divided by B by C, the denominator's denominator goes to the numerator. So it is AC by B. If it is A by B divided by C by D, the denominator's denominator goes to the numerator. This gets multiplied here. So it is AD divided by BC. And yeah, we should also remember that A plus B by C can also be written as A by C plus B by C. It has the same denominator, but we cannot write this. A by B plus C cannot be written as A by B plus A by C. This is false. So knowing these, let us continue with our problem. We got the midpoint between 3 by 5 and 4 by 5 as 7 by 10. Now let us find the midpoint between 7 by 10 and 3 by 5. So that is 3 by 5 plus 7 by 10 by 2. So if I take an LCM, that would be equal to 3 2s are 6 plus 7 by 10 by 2. So that would be equal to 7 plus 6 is 13 by 20. Okay. Now what I'll do is I'll take the midpoint between 7 by 10 and 4 by 5. So that would be equal to 7 by 10 plus 4 by 5 by 2. If I take an LCM, that would be 7 plus 8 by 10 divided by 2. This would be equal to 15 by 20. So what are the three numbers between 3 by 5 and 4 by 5? They are 13 by 20, 17 by 10 and 15 by 20. So this is the answer. But let me take, I have some problem in taking LCM and do writing the fractions each time. I get confused. So what do? I go for another method which is simpler. If there are more numbers, for 3 itself, it covered the whole page. Now, if it was 10 numbers or 5 numbers, that would take a much more longer time and much more longer space in this method. So we will adopt another method. So we will take the same problem, but insert 5 rational numbers between 3 by 5 and 4 by 5. In this method can only be applied when the denominators are same. Here the denominator is 5 and 5. So yes, this method can be applied. And we have to take n. N is the number of rational numbers. How much rational numbers should be inserted between 3 by 5 and 5 by 5? In this case, n is equal to 5. And we know what is R and S. R is 3 by 5 and S is 4 by 5. We saw in the earlier problem. So here, what we should do is, we have to add n plus 1 to the numerator and denominator of R. That means when n is 5, n plus 1 is 6. So we have to multiply and divide the numerator and denominator of R. That means 6, n plus 1 is 6 by 6 into numerator R, 5 by 3 by 5. The same thing with S. It is 6 by 6 into 4 by 5. So what do we get? 6 3s are 18, 6 5s are 30. Here it is 6 4s are 24 by 6 5s are 30. So now I have to insert two numbers between 5 numbers between 3 by 5 and 4 by 5. But I can cancel. This is nothing but 3 by 5. This is an equivalent rational number. This can also be written as 3 by 5. This is again an equivalent rational number. That means it is not a coprime. This is not a coprime number. We have 6 as a common factor between them. So if I divide them, I get 4 by 5. So 3 by 5 can be written as 18 by 30 and 4 by 5 can be written as 24 by 30. So now what do? There is 18 by 30, there is 24 by 30. I need to add 5 numbers. So I write the next number as 19 by 30, then 20 by 30, 21 by 30, 22 by 30, 23 by 30. So these are the 5 numbers. This is all. It is so simple. We need not make this into fraction with co-prime numbers. We can leave it like this in the final exam, in the exam, or else we can simplify if we have time. So this is more simpler. We have to just multiply the multiply r and s with n plus 1 on the numerator and denominator, and we get some numbers. And the numerator, we have to increment it by 1 and write down the numbers. It is as simple as that. 18 by 30, 19 by 30, 20 by 30, 21 by 30. There are 1, 2, 3, 4, 5. 5 numbers. So this is more simpler. Even if they ask for 10 numbers, you can do that. Now let us look at another problem. Let us insert 100 rational numbers between minus 4 by 11 and 7 by 11 in the second method. So what is n? N is 100. Here the denominator is same, 11, 11. So I can use the second. So I can use the second method. So how do I go about it? N is equal to so n plus 1 would be n plus 1 would be equal to 101. So what should I do? I should multiply minus 4 by 11 into 101 by 101, and I should multiply 7 by 11 into 101 by 101. Sir, this is difficult, sir, to multiply. What to do, sir? So let us do one thing. They have asked for 100 rational numbers. So is there any problem if we find more rational numbers? That means there are infinite rational numbers between this point and this point. So I would like to find around more points. So I will take n as 109. So I'll find 109 rational numbers. So what is n plus 1? N plus 1 would be equal to 110. So now if I multiply this minus 4 by 11 into 110 by 110 and 7 by 11 into 110 by 110, what do I get? I can divide 11 10 times 10 times. So this would be minus 40 by 110. This would be 70 by 110. Now how much numbers did now this is simple. If I keep on adding minus 39 by 110 minus 38 by 110, I keep on adding, how many numbers do I get? Till 69 by 110, I get 109 numbers. But how much numbers do I need? I need 100 rational numbers only. So what do? I write it like this: minus 40 by 110, minus 39 by 110, minus 38 by 110, minus 37 by 110, product minus 1 by 110, and 0 is also included. Then I start with 1 by 110, 2 by 110, and I go like that. I go till 60 by 110 and 70 by 110. I do not write 61 by 110, 62 by 110, and 69 by 110. because I don't need those 9 numbers. I only need 100 rational numbers. So these are the 100 rational numbers. So we can look here that we can find more numbers also for the sake of simplification of the problem. We have to still remember that between any 2 points, between these 2 points also, there are infinite rational numbers. Now let us look at another method with an example. In this problem, we have to find 10 rational numbers between minus 15 by 13 and 6 by 13. Minus 5 by 13 and 6 by 13. In this method, the second number, this should be greater than the first number. That means S should be greater than R. This is S, this is R. S should be greater than R. Then we will find something called D. What is D? D is S minus R by N plus 1. What is N? This N is equal to 10. N is 10 out here. So in our case, it is, what is D? D is equal to S minus R by N plus 1. That is 6 by 13 minus of minus 5 by 13 by 10 plus 1, N plus 1. So what is this? This is nothing but 11 by 13. 11 by 13 divided by 11. So this is 11, 11 gets cancelled. So I would be left with 1 by 13. So now I have to find R plus D. R plus D, that is equal to minus 5 by 13 plus 1 by 13. How much is that? Minus 4 by 13. Then I have to find R plus 2D. Or I can do R plus D plus D. That is minus 4 by 13 plus 1 by 13. That is equal to minus 3 by 13. So if you look at this, it was minus 5 by 13, then minus 4 by 13, minus 3 by 13. I know the sequence. I know you know the sequence. It is minus 5 by 13, minus 4 by 13, minus 3 by 13, minus 2 by 13, minus 1 by 13, then it's 0, 1 by 13, 2 by 13, 3 by 13, 4 by 13, 5 by 13 and 6 by 13. So where did we get this formula from? We got this from arithmetic progression, which we will be studying in our 10th standard. So this is another method. So now let us look at another problem. Find 6 rational numbers between 3 and 4. In this problem, we'll do one thing. Oh my goodness. We'll do one thing. Let us write as we write in the exam, so that you would be familiar on how to frame sentences while writing your answer. Or else if you write it as we wrote it in our problems in here, teachers will think that we have copied from somebody else. Okay. So to find 6 rational numbers between 3 and 4. So we have to start with given to find 6 rational numbers. Therefore, n is equal to 6 and n plus 1 is equal to 7. Okay, so we will go with the second method in this. So n plus 1 is equal to 7 and we have 2 numbers given. So let us write 3 and 4 as 3 by 1 and 4 by 1. So by using the formula, by using n plus 1 by n plus 1 into numerator by denominator, we can write 3 by 1 into 7 by 7 and 4 by 1 into 7 by 7. So what is this? This is 21 by 7. This is 7 4s are 28 by 7. So we know in the second method it is very easy. It is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. So the 6 rational numbers between 3 and 4 are, they are 1, 2, 3, 4, 5, 6. You should not start with 21 by 7. It is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. So this is the answer. So I request you to practice some problems from the exercise in the textbook, and in the next class we will look at irrational numbers. Till then, have a nice time. Bye.